All right, so this week in the support class, it's going to feel like we're dealing with sort of an odd topic because we are nearing the end of our parent course. We're doing a lot with integration. We've seen a lot of calculus up until this point, yet in the support class, I'm looking at something so far back in your math history. It's something you would have dealt with as far back as elementary school. We're specifically working with fractions. And the reason I wanted to focus on this now instead of much earlier in the course is, as you have probably noticed by now, a lot of the time when we're working with definite integrals and we're using the fundamental theorem of calculus to evaluate them, the arithmetic that we end up having to do involves a lot of adding and subtracting fractions. And this is not new to you, I'm sure, but a lot of people who struggle with math will say that fractions is one of the areas that they have the most struggles with when they're talking about their kind of basic arithmetic skills. So with that said, there are some techniques that I'm going to talk about that's going to help hopefully with that. And the emphasis here is actually going to be mental math. All of the stuff that we do in this section has multiple approaches that you could take. And you could, like for example, the first section we're looking at is LCMs, finding LCMs of numbers. In pre-algebra, you're taught how to do this by breaking numbers down into factor trees and then finding prime factorizations and then using that to construct a least common multiple. And that's an important technique to know. It's good, it works. It is way too time consuming for what we're doing in this class. If that was all you were being asked to do for a problem, go for it. But if you're doing this for the sake of finding the result of a definite integral, it's an enormous waste of time. So we want faster, more efficient techniques for dealing with fractions as they come up in these definite integral problems, because those problems tend to have a lot more than just the fractions that you're dealing with. So we're going to start with this concept of least common multiple, or LCM, because this has to do with finding common denominators in fractions, which is what we're going to be using in the next sections down here. So I have three problems here, and what we want to do is find the least common multiple. If you don't remember what a multiple is, a multiple is a number that you can get by counting by some other number. So for example, if I wanted to list the first few multiples of 5, then I would count by 5s. 5, 10, 15, 20, 25, 30. All of those are multiples of 5 because I get to them by counting by 5s. Or a little bit more mathematically speaking, all of those numbers are equal to 5 times some positive integer. So that's how we think about multiples. Common multiples are if I take two different numbers and look at their multiples and see which multiples they have in common, as the name implies. So if I look at the multiples of 3, 6, 9, 12, 15, 18, and if I look at the multiples of 5, 10, 15, 20, 25, so on and so forth, they both have 15 in common. 15 is a multiple of both of those numbers. 30 is also a multiple of both of those numbers. 3 times 10 makes 30, and 5 times 6 makes 30. So those are both multiples, or 30 is a multiple of both of those numbers. LCM, as the name implies, is the least of those common multiples amongst those lists. When you are first taught about this concept, even before you talk about the factor tree thing that I mentioned about earlier, in elementary school, they'll teach you to write out multiples for all three of these numbers. Write out the multiples of 4 up to a certain point. Write out the first several multiples of 6, the first several multiples of 8, and then find the first thing that shows up in all three of those lists. Again, that is way more time consuming than what we want to be doing here. So I want to talk about faster techniques for problems like this. And again, the emphasis is mental math. You want to have to not write down so many steps. So here's a way of dealing with least common multiples. If you're given 2 or more numbers, find the largest number in that set of numbers. Okay? 8 in this case. Then look at the other numbers in your list and ask for each one of those, is this a factor of that largest number? 4 is a factor of 8. Is 6 a factor of 8? No. The fact that 4 is a factor of 8 implies that every single multiple of 8 is automatically also a multiple of 4. And I'll let you think through why that's the case if you didn't know that fact already. 6, however, is not a factor of 8. And so in order to get a least common multiple, what I'm going to start doing is counting by this largest number. I'm going to count by 8s. So 8 plus 8 is 16. Is 6 also a multiple of 16? It is not. I don't need to check 4. I already verified that 4 is a factor of 8, so we're kind of done dealing with 4. 6 is not a factor of 16. So when I'm counting by 8s, 8 didn't work, 16 didn't work. I keep counting by 8s. 16 plus 8 is 24. Is 6 a factor of 24? It is, because 6 times 4 is 24. That automatically means that 24 is the least common multiple of these three numbers. So again, what am I doing? Start with your largest number and ask, are these two numbers a factors of this number here? One of them is, one of them was not. If they're not both factors of this largest number 8, start counting by 8s until you get to a number that these are both a factor of. And you will eventually get to that number, but depending on what it is, you may have to count out for a little while. It only took us a couple of steps to get there. 12 and 30, I want to find the least common multiple of these two numbers. Okay, so for this, the way that we can do this is we can also do what we did here, ask, is 12 a factor of 30? It is not. And so we could then start counting by 30s until we find a factor of 12. And that wouldn't take you too much work here, but I want to talk about one other shortcut just so you have a different tool that you can use. Okay. Sometimes it is easier to find the GCF, which stands for greatest common factor of two numbers, before you can find the least common multiple. Sometimes it's easier to find that GCF. GCF, greatest common factor, means I'm looking at the factors of these two numbers and finding which factor do they have in common, which is the largest of those common factors. So 12, its largest factor is itself, but 30, as we already said, does not have 12 as a factor. And I can think of, 12 times 1 makes 12. What times 2 makes 12? Well, 6. That means 6 is the next largest factor of 12. So how do I find, is 6 also a factor of 30? Yes, because 6 times 5 is 30. So I can say that the GCF of 12 and 30 is 6, okay? Now, why do we care about that? We're being asked for the LCM, not the GCF. The reason this matters is because there is a neat relationship between least common multiple and greatest common factor that you can use to find a least common multiple. Once you have found your GCF of these two numbers, pick either one of them and divide it by this GCF. I'm going to pick 12. So if I did 12 divided by my GCF, which is 6, I would get 2. Take that number and multiply it to the other number in that list, 2 times 30. 60. That's the LCM. And you can verify it. 12 goes into 60, 30 goes into 60. And it's the smallest number that they both go into evenly. So that's another technique that you can use. I would recommend only using this one when you have two numbers in your list. We did not have that previously. But again, if it's not difficult to find the GCF of those two numbers, find it. And all of these steps that I wrote here, typically you would keep in your head. You wouldn't have to write these out, but I just wanted to do it for reference. Find the GCF, pick one of those two numbers, maybe the smallest one that tends to be easiest, and divide by that GCF. Because it's a factor, you'll get a whole number when you do that. Multiply that number to the other number that you didn't do anything with yet, and that's your LCM. Okay? All right. Here's one more. I want to find the least common multiple of these three numbers, but these three numbers include unknowns, A's and B's. Okay? I need the least common multiple of all three of these. If I look at just the coefficients, 3, 6, and 9, ignore the A's and the B's for a second. I can find the LCM of those fairly easily. Does 3 go into 9? Yes. So 3 is automatic. All the multiples of 9 will automatically be multiples of 3. Does 6 go into 9 evenly? It does not. So start counting by 9s. 9 plus 9 is 18. Does 6 go into 18? evenly? Yes. 6 times 3 is 18. That means 18 is the LCM of 3, 6, and 9. What do I do with the A's and the B's? Well, look at all of them. I have an A and a B and an A and a B. I'm going to put A, B in my LCM, and that's going to be my LCM. How do I know that that works? Well, again, if this is a common multiple of these three numbers, then I should be able to multiply each one of these by something to get 18AB. Notice 3 times 6 is 18. I don't need to do anything with the A. There's already an A there. But then if I multiply by a B, that'll put the B in here. So 3A times 6B gives me this. 6B times 3A gives me this. And 2 times 9AB gives me this. Okay, so those unknowns, those letters in there can be worked out that way. So the point of doing all this LCM stuff is to be able to quickly find least common denominators for fractions, okay? Now, typically what you would do in a problem like this, where you're working out this fraction arithmetic, is you would start by getting a common denominator, rewriting all of your fractions with that common denominator, and then adding or subtracting the numerators together to get your answer. And the point of this exercise is to cut out that middle step. Okay, there's still going to be a middle step, but we're going to do it with a little less writing than you normally would. So let's look at the three denominators here, 4, 8, 16. Does 4 go into the largest of those numbers, 16? Yes, 4 is a factor of 16. Is 8 a factor of 16? Yes. That means that 16 is automatically the least common multiple of those three numbers, which means it's also the least common denominator of these three fractions. So that means when I do the work here, 16 is going to be the least common denominator that I use. It's going to be the denominator of my fraction. Now at this step, I'm going to convert the two fractions that don't have 16s in the denominator into 16ths. And I'm going to think, what would I multiply this number by to make 16? Well, 4 times 4 is 16, and so I would need to multiply that numerator by 4 as well. 1 times 4 is 4. Minus, what do I multiply 8 by to make 16? Well, it would be 2. So 3 times 2 is what happens up in the numerator. That's 6. And then because I have a 9 here, because I already have a denominator of 16 in this fraction, nothing changes, so my numerator stays the same, plus 9. Okay? Then you just do the addition up here. 4 minus 6 is negative 2, plus 9 is 7. I get 7/16 as the final answer. Sometimes you can do this part mentally. A lot of the time, it's too much to try to juggle in your head to hold all of these numbers in there. But where this is a little bit more efficient than what you would normally do is I didn't bother writing 4/16 minus 6/16 plus 9/16. I don't need to write that 16 3 times. I already know it's going to be the same denominator each step of the way. So I'm just writing it once and then doing all the arithmetic in my numerator. This is to make it go a little bit faster when you're doing problems in definite integrals and stuff like that. Let's take a look at another one. 6/25 plus 1/200 minus 3/400. Okay. So now take a look at the least common denominator. Does 25 go into 400? Absolutely it does. Does 200 go into 400? Absolutely it does. 2 times 200. So these are both factors of 400, which means my least common denominator is automatically 400. Okay? Now I just need to get these numerators. When I think about 25 and how it goes into multiples of 100, it's helpful to think in terms of money, I've found. So I think of hundreds as dollar amounts. 200, if I interpret that as 200 cents, that's $2. 400, if I think of that as 400 cents, that's $2. 25 cents, then I would think of as a quarter. If I know that there are 4 quarters in a dollar, then how many would there be in $2? 4 times 2, that's 8, right? How many would there be in $4, which is, again, that's the common denominator I'm looking for. 4 quarters in $4, 4 times 4 is 16. So I have 16 times 25. That's how I'm going to get this 400 right here. So I have to do 16 times 6, okay? So what is 16 times 6? 16 times 6 is 96. Okay. Then I have this next fraction here. This one is much easier because 200 times 2 is 400. So I'm just doubling my numerator, plus 2. And then this guy, nothing changes, minus 3. From here, the arithmetic is super straightforward. 96 plus 2 is 98. Minus 3 is 95. Okay. At this step, I could just leave that as my answer, but typically with fractions, we want to simplify them. And I can see that both my numerator and denominator are divisible by 5 here. So I would divide by 5, which gives me 9 80ths is what that becomes. Okay. Couple more problems to do. This one and this one, they both involve some letters, right? And I intentionally did one problem where the letters, the unknowns, were showing up in the numerator for one problem and then in the denominator for another problem. All right, so let's take a look at this example. First of all, this 14 here is not given to me as a fraction. So when I'm looking for my common denominator, I'm really only looking at these two. Does 7 go into 21 evenly? Yes, so that means 21 is my least common denominator. So let's do this, 21. Now let's see what each of these numerators would be. So to get 7 to become 21, I'm multiplying it by 3. 3 times 2a is 6a. I already have the denominator I want there, so the numerator does not need to change. I get plus 4b. And then here, negative 14, I could just put a minus 14 out here, but typically we want to consolidate everything into a single fraction. So what I could do is think of this as 14 over 1, and then multiply the numerator and denominator by 21 to get a common denominator. So what is 14 times 21? I could do that off to the side, but what I would get is 294. This is how I have to leave my answer because I have a's and b's and a constant. None of those are like terms. I cannot combine anything. So this is as simplified as I can make that. One last problem to go. 1 over a plus 2 over b plus 3 over c. And in this problem, what we're trying to do is add everything together, but I don't know any of the denominators. I'm given these unknowns here. I have no way of determining if a is a factor of b or a factor of c or anything like that because I don't know how they relate to each other. So the only real way to get a common denominator is to multiply all three of them together. A, B, C, like that. Now when I look at the numerators, I think, what do I have to multiply this fraction by to get A, B, C at the bottom? There's already an A, so I have to multiply it by a BC. I'm going to do the same to my numerator. 1 times BC is just BC. Over here, I already have a B in my denominator. To make it into ABC, I need to multiply it by AC. 2 times AC looks like 2AC. Finally, here, I'm missing the A and the B, but I have the C. So I have to multiply the numerator and denominator by AB to get that common denominator, which means I have 3AB in my numerator. Okay? Again, this is old news. This is old news. You've done this kind of stuff in algebra or pre-algebra, elementary school. It's been a long time. But the purpose behind this is to develop mental math techniques because you don't want to be spending a lot of time dealing with these fractions or making like mistakes when you're working with them in those definite integral problems. So that's going to be it for this week.